welcome to O-Checker, detection of malicious documents through deviation from file format specifications. We're in the Jasmine Ballroom with Yuhei Otsubo. Before we begin, a few brief notes. Stop by the Business Hall, located in Bayside AB. The Black Hat Arsenal is on the Palm Foyer on level 3. And of course, the Arsenal reception at 5 o'clock. If you haven't picked up your merchandise today, it is your last chance to visit the Black Hat Swag bookstore and visit the Kali Linux Lab in Mandalay Bay A. And thanks in advance for putting your phone on vibrate. It makes it easier for the rest of us to ignore the ringing while you wait for your voicemail to pick it up. And here we go.
Thank you. Hello. I'm Yuhei Otsubo, National Police Agency of Japan. Today, I'd like to talk about my document malware detection tool, O-Checker. My presentation consists of two parts. The first one is an introduction to O-Checker. The second one is a demo to show you how O-Checker works. I guess targeted email attacks would be a big issue in your country. Typically, a targeted email attack is carried out with malware attached to an email. This pie chart shows the 5 types of malicious attachments found in 2014. The document file account for around 60% in total. This 60% is not a small number. So that is the reason I created O-Checker to detect those malicious document files. Now, let me talk about the overview of O-Checker. O-Checker is a document malware detection tool, but its target is limited to droppers. One of the benefits of O-Checker is that it can detect document malware without executing malicious code. So it is safe to use, and the result is independent of analysis environment. O-Checker focuses on the deviation from document file format specification. The specifications are stable and available in open source. O-Checker can detect document malware with a fairly high rate. Here, I mention the type of a malicious document file. I gathered various malicious document files. In the case of targeted email attacks, most of malicious document files are droppers. On the other hand, in the case of opportunistic attack, most of malicious document files are downloaders. Why? In the case of targeted attacks, victims are tricked into opening malicious documents because the email have charming title and body. If the malware does not show any document, the victim notices that this email is suspicious, and the infection will get noticed in a short time. So, document malware shows a decoy document file to reduce vigilance. To show the decoy document file reliably and quickly, document malware tends to be a dropper. In this slide, I'd like to briefly talk about how O-Checker detects malware. The left half of this slide shows the state of any document file format. Generally, Microsoft Word, Excel, PDF, and other document files have the different file format. Based on each file format, document processing software displays its content. For example, Microsoft Word for Word document file, Microsoft Excel for Excel spreadsheet, Adobe Reader for PDF file. In the case of malicious document files, executable files and decoy document files are forcibly pushed into the document file. But this extra data is not displayed by document processing software. So, the malicious executable file is present in the stored content, but not present in the displayed content. This mismatch between the displayed content and stored content causes the deviations from file format specifications. OChecker checks these deviations to detect malicious document files. I obtain various malicious document files from Japanese organization. These samples were actually used in the targeted email attacks. The breakdown of the obtained samples is shown in this slide. Among the listed file types, you may not be familiar with JTD file. JTD file is used in the Japanese word processor named Ichitaro. So, Ichitaro is as famous as Microsoft Word in Japan. So, when a vulnerability of Ichitaro is found, it is often used in targeted email attacks. OChecker checks 8 kinds of deviations from document file format specifications. As I do not have time enough to cover all the deviation structure, please refer to my white paper for more information. Here, I explain in the example of what I call PDF deviation. PDF file consists of various kinds of objects that forms document structure, and we can grasp the overview by tracing the link of trailer object first. All objects should have a role, but the object that attacker embedded has no role at all, which means no object can refer to the object. If you find such object in PDF file, there might be a high possibility of malicious PDF file. Now, I'm going to briefly show you how to use OChecker. OChecker requires Python. So, OChecker can run on any OSs as long as PDF installed. Usually, no additional package is necessary to run OChecker. However, if you'd like to analyze an encrypted PDF file, PyCrypt is required to deal with encryption in the PDF file. In normal use, no parameter is required. At the bottom of this slide, a command example is shown. You only need to give the suspicious file to OChecker I'd like to start OChecker demonstration. I will show you how OChecker works with a malicious PDF file. As I mentioned, all you have to do is passing a document file as a parameter to ochecker.py. If the file contains a deviation, OChecker shows malicious message. If the file does not contain any deviation, OChecker shows none message. In this demo, you can find the document file is malicious because OChecker shows malicious message. Now, I would like to show you how to analyze document file by OChecker. I explained this with the previous PDF file. OChecker's components contain pdfanalysis.py that can analyze PDF files. Let's pass the previous malicious PDF file onto pdfanalysis.py as a parameter. You can see a bunch of logs on the screen. These logs show a structure of the PDF file that was passed on as parameter. OChecker analyzes the structure of the PDF file and shows the offset address of each object and shows each object relationship. That can help you to grasp the basic structure of the PDF file. Let me explain this with an example. You can see that there is information about XML metadata in object number 7. Now, let's open this PDF file for testing. This PDF file requires a password. Actually, this PDF file is encrypted with AES encryption. PDF file encryption, as a matter of fact, only encrypts the object about strings and streams, which means that the PDF structure is still intact, and OChecker can check the PDF file structure. So let's have a look at analysis of this PDF file in detail. OChecker can decrypt PDF file encrypted with AES. The P option specifies password. Black hat is this PDF file's password. You can see more information than last time because stream objects are decrypted. For example, you can see you can see that there is information about JavaScript in object number 8. You can see the information of each object by specifying command line option. The O option specifies object number to show. And then, O-checker shows the information in JSON format. As you can see on the screen, JavaScript instance is stored in object number 11. So the object defined in each tag can be exported in JSON. Streams which store binary data are encoded by various filters. With the S option, O-checker can decode streams and export the decoded data. The usage of S option is the same as O option. The contents of the stream are displayed. O-checker can easily exploit code from an AES encrypted PDF file. I would like to mention PDF file encryption for a short time. You can decrypt a PDF file with either two passwords, owner password and user password. Owner password is for editing. User password is just for browsing. If user password is specified as empty, the browsing software does not require a password, and the contents will be displayed quickly. However, there are few analysis tools that can decrypt AES. It is difficult to analyze. Clever attacker knows this characteristic very well. So that's why most of malicious PDF files are encrypted. If PDF files encrypted, O-checker try to decrypt these files with empty password. If the decryption is failed, it has no problem for detecting malware. As I mentioned, PDF file encryption is only encrypted the object about strings and streams, which means that the PDF structure is still intact, and O-checker can check the file format structure. This is the end of O-checker introduction. The deviation detection methods implemented into O-checker might not be so complicated, but document malware detection rate is fairly high. I hope my presentation is beneficial for you. Thank you for your attention.